Hello and welcome to the next lesson of the particle model of matter. Today's video is going to focus on the topic internal energy. So before we start anywhere today, I want to talk about the difference between temperature and heat. So first of all, what is temperature? So temperature is a measure of how hot or cold something is. And in the lab, you will use a thermometer to measure the temperature. Heat is a form of energy, and it actually depends on the kinetic energy. Now we get to a concept of something called internal energy. The internal energy is actually the sum of the kinetic energies which each particle possesses and the sum of the potential energies. So the sum of the individual kinetic energies and the sum of the potential energies of all of these particles make up the internal energy of a system. And remember, a system is an object or a group of objects that we've decided to study. Now, both of these elements to internal energy can change. Now we know that kinetic energy from a previous video is proportional to temperature. As we increase the temperature, the kinetic energy of these particles increases. They vibrate quicker, they move quicker if it's in a gas. Well, that means then that the kinetic energy is going to be affected by the temperature. That means you increase temperature to get more kinetic energy, that increases the internal energy. However, we have to consider potential energies. Now, potential energy is not gravitational potential, but the potential energy is concerned with the spacing between particles. That means that as the spacing increases, the potential energy increases. That means my gas has the most potential energy because my particles are the most spread out in this state of matter. Well, as a quick summary to remember this, I just remember if there is a temperature change, then that's going to refer to my kinetic energy. And if there is a state change, that's going to refer to my potential. So if I'm changing state, my particles are becoming more spread out, the intermolecular forces are being broken, the bonds between particles are being broken, and my particles are becoming more spread out. Well, to illustrate what I mean by this, we're going to focus on two different scenarios. And for this, we're going to think about melting ice and we're also going to think about warming water. So the first thing I want us to consider is the temperature. So the first thing I want us to consider is the temperature. And let's think about warming water. What is happening to the temperature as we warm water? Well, we'll actually find out that the temperature is increasing. So the temperature increases. When we're melting ice, the temperature doesn't change. The temperature actually remains constant. Now, the temperature remains constant because the energy is being used to break the bond between particles. So that energy is no longer being used to change the temperature. So when we're melting ice, the temperature always remains constant. When we're warming water, it's increasing. I then want us to think about the particle diagram for this. Now, warming water is going to remain a liquid. So we can draw our state of matter for a liquid. So here's our liquid. And we know as we increase it, their kinetic energy is going to increase. However, when we're melting ice, we're actually changing state. So what we need to show is we need to show, first of all, the state as a solid, but some will then start to break away. So here we're showing it's a solid, and then they're starting to stop from being regular to becoming irregular because we're having that state change. Now, I want us to think about two elements now. I want us to think about the kinetic energy, but also the potential energy. So, The kinetic energy, we said, refers to if there's a change in temperature. Is there a change in temperature when we melt ice? No. So that means our kinetic energy remains constant. Let's do the same sort of logic. Warming water, is there a temperature change? Yes. What's happening to kinetic energy? Well, that is increasing. And the final thing I want you to talk about is potential energy. We just said potential energy refers to that particles becoming more spread out or closer together, and it happens under the change of state. So what's happening to potential energy as we're melting ice? Well, as we're melting ice, the particles become more spread out, so it increases. As we're warming water, is there a state change? No. So the potential energy stays the same. Now, I want you to use this logic, and I want you to have a go at the next few things. I want you to think about boiling water. The final thing I've got to say in this video on internal energy is it can also happen when we cool things down. So we're adding heat to the system here. But if we think about it, if we're cooling water, so we're taking it back to an ice, then the temperature is decreasing and the kinetic energy is decreasing because the temperature is decreasing. But again, the potential energy stays the same. As we're changing state again, as we're solidifying or freezing, then that potential energy is going to decrease because my particles are coming back together and getting closer together. So make sure you can do it both ways.